Okay, moving on to behavior and feeding. Always key areas. Advanced imaging seems central here. Sonar, stereo cameras.
Yeah, these systems generate a ton of data. And AI, often things like YOLO-based object detection, is helping quantify behavior precisely, linking behavior to health or stress.
And weight estimation.
Right. Combining sonar imaging with methods like K-nearest neighbor regression lets them estimate fish weight from length, non-invasively.
That's useful.
Very.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production.
Welcome. Today we're doing a focused deep dive on AI in U.S. aquaculture.
That's right.
We're digging into a pretty significant review. It looked at 57 studies, peer-reviewed, all from 2020 to 2024.
Very recent work.
Yeah, and the goal here is really to pull out the key practical applications of AI, but also, importantly, the technical challenges still facing us.
Absolutely. It's a solid review. It gives a really structured look.
It does. It covers disease diagnostics, biomass, behavior, water quality, feeding, even remote sensing for farm monitoring.
And it categorizes everything nicely. The AI applications themselves, the specific tech being used, the methods, and those implementation hurdles. It's a great snapshot.
Okay, let's jump into those applications. Disease diagnostics is obviously a big one. The review highlights image-based machine learning. What's standing out there?
Well, there's quite a bit. We're seeing techniques like support vector machines, SVMs, doing well in classification, and then more complex stuff like mask RCNN, and definitely deep learning CNNs, ResNex 101, UNet. These are being applied effectively for early disease spotting in species like salmon and tilapia. The detail these models can pick up visually is pretty impressive.
And it's not just detecting diseases after they happen, right? There's work on predicting stress, too.
Exactly. That AI-assisted stress recognition model they mentioned, it uses knowledge distillation, which is clever.
How so?
Well, it takes a big, complex model and sort of teaches a smaller, lightweight one like the GhostNet architecture mentioned. Makes it feasible for on-farm, real-time systems.
And the accuracy?
Reported between 94% and 98%. That's significant for, catching problems early, managing fish welfare proactively, big implications for productivity.
Okay, moving on to behavior and feeding. Always key areas. Advanced imaging seems central here. Sonar, stereo cameras.
Yeah, these systems generate a ton of data. And AI, often things like YOLO-based object detection, is helping quantify behavior precisely, linking behavior to health or stress.
And weight estimation.
Right. Combining sonar imaging with methods like K-nearest neighbor regression lets them estimate fish weight from length, non-invasively.
That's useful.
Very. And that YOLAR4 tiny ECA model for fry feeding status, an F1 score of 0.96. That's real-time precision for optimizing feed right from the start. Less waste, better growth.
It's interesting how it spans from the micro, like fry feeding, to the macro environment. Let's talk water quality monitoring, UAVs and sensors.
Absolutely. Deep learning models paired with UAVs, drones, and wireless sensor networks. It's about getting a dynamic picture.
The review mentions a specific system, Dynamic Network Surgery, DNN.
Yes, combined with UAV spectral imaging. They achieved R-squared values around 0.80 for dissolved oxygen, 0.83 for turbidity.
Pretty good R-squared values.
They are, and it really highlights the power of fusing data from multiple sources, sensors in the water, imaging from above. It gives a much richer understanding of the environment.
Okay, biomass estimation. That's always been a tough nut to crack accurately without handling the fish.
Definitely. But stereo vision combined with deep learning, like the DL-YOLO model mentioned, is making real headway.
The R-squared values look very high, up to 0.99 in some cases.
Yeah, the reported values are impressive, ranging from 0.87 up to 0.99.
Wow.
And crucially, these models are getting better at handling things like fish posture, or when fish overlap, which used to really throw off visual estimates.
So that means better inventory counts, more precise feeding?
Exactly. Better feed management, better stocking density decisions, more reliable yield forecasts. It all connects.
And the last application area mentioned is remote sensing, mapping aquaculture zones.
Right. Using AI models like ResUnet, SegNet, UNet++ on satellite or drone data.
For what exactly?
For mapping where aquaculture is happening, especially in coastal areas. One model hit 95.9% accuracy using things like dilated convolutions and self-attention mechanisms.
I see. So that's more for planning and regulation.
Precisely. Large-scale spatial analysis, figuring out suitable new sites, checking compliance with environmental rules. Very useful at a strategic level.
Okay, so the potential is clearly there. The tech is advancing. But the review doesn't shy away from the challenges. Data seems to be a big one. Scarcity and bias.
A huge one.
Yeah.
Any AI model is only as good as the data it's trained on.
Right.
And there's often a lack of enough high-quality, well-labeled data, especially for species that aren't the big commercial ones, or for farms outside the main research hubs, like in Asia. And if the data you do have is biased.
The AI learns the bias.
Exactly. Leading to potentially unreliable results. It's a fundamental bottleneck.
Then there's the cost. These systems, high-res cameras, IoT sensors, the computing power, it's not cheap.
Not at all. That's a major barrier to entry, especially for smaller operations here in the U.S. The upfront investment plus ongoing costs.
Yeah.
It can be prohibitive, even if the long-term benefits look good on paper. We need more cost-effective solutions.
And it's complex technology. It requires expertise that bridges aquaculture and data science.
Which isn't always easy to find. You need the fish farmers, the biologists who understand the practicalities of the environment, the animals, working hand in hand with data scientists who know the algorithms, the modeling, the software. That collaboration is absolutely essential to build tools that actually work and are useful in the real world.
The review also touches on social acceptance, skill gaps among operators.
Yeah, that's important too. Getting buy-in from the people who have to use these systems day to day. Training is needed.
And maybe some ethical points around AI making health decisions, though the review focused more on technical aspects.
It did, but transparency in how these AI systems reach conclusions, especially for health or treatment, is certainly an underlying consideration as they become more integrated.
Looking at the geography of the research, China seems to be leading in terms of published output.
Yes, the review points that out clearly. A lot of work coming out of China across various areas: mapping, feeding, behavior, biomass. It reflects their large industry investment.
But other countries are active too.
Oh, absolutely. Significant contributions noted from Taiwan, the U.S., Norway, Japan. It's definitely a global research effort.
And the timeline shows a big jump in publications recently, 2022 to 2023.
Yeah, a real surge. It indicates that interest and research activity are accelerating rapidly. People are really seeing the potential here and jumping in. It's a fast-moving field.
So pulling it all together, AI clearly offers huge potential for U.S. aquaculture. Better precision, disease control, efficiency gains.
The promise is there.
But, and that's a significant but, we need to tackle these technical challenges head on. The data issues, the infrastructure costs, the need for that interdisciplinary expertise.
Absolutely right. Those are the hurdles we need to overcome to really unlock the benefits widely across the industry here.
So thinking about the future and considering those capabilities we've discussed alongside the hurdles, what specific technological developments do you think are most critical? Where should the focus be for AI in U.S. aquaculture moving forward?
That's the key question, isn't it?
It feels like, maybe getting better, cheaper ways to gather good data in diverse farm settings, and maybe developing AI tools that are powerful, yes, but also robust, more affordable, and frankly easier for operators to actually use.
I think you've hit it. Data acquisition innovations and user-friendly, cost-effective, reliable AI tools seem paramount. That combination could really drive adoption.
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.